Alright.
Yes. Bye.
So, yesterday we had stuff like this. You guys remember what the -1 did to the graph? Made it go down 1. Do you remember what the 2 did to the graph? Made it go up twice as fast, so it makes it narrower. So if it goes down 1, the vertex is at 0, -1. If you do times 2, it just looks narrow. I still have you guys plug in x values to find what it looks like. Today's are going to look more like this. Okay. The book calls this Vertex Form because it's kind of easy to find the vertex. Standard form of a quadratic looks more like this. And those are definitely trickier to graph. I think we're going to do that like on Monday maybe. One of the last things we do. Vertex form, this is much more convenient. What does the -3 directly on the x do to the graph? We've seen this before. Moves it right 3. And what did this do? Down 1, just like that. So when it's directly on the x, it moves left or right, but it does the opposite of what it looks like. So it doesn't go left 3, it actually goes right 3. And this moves it down 1. The 2 out here still makes it go up twice as fast. That doesn't change. Notice it's not in the parentheses. Yesterday, what did a negative do right there?
Makes it go down.
Flips it upside down, so it would be going down. So just a really quick rough sketch. The vertex is at 3, -1, and it's going down quickly.
Yeah.
That's what the 2 does, so it's pretty narrow, kind of narrow. So it would look something like that. That's a really rough sketch. I didn't find all the points. How do I make the graph flatter? Like multiply by something less than 1. So instead of a 2 right there, if I put like 1/2 or 1/3 or some fraction less than 1. Okay, that's pretty much it. Oh, one more thing. So we talked yesterday about how a parabola is always symmetrical, right?
Yeah.
That line right down the middle, the line of symmetry that splits it in half, they call it the axis of symmetry. I don't suppose you guys would know what the equation of a vertical line would look like, do you? This looks like this, x equals. You guys remember how a horizontal line was like y equals -2 or something? This vertical line would just be x equals 3. Okay? Because all the x values on that line have a value of 3. So basically, the x coordinate of the vertex is the same thing as the equation for the axis of symmetry. If the vertex is at 3, -1, x equals 3 is the axis of symmetry. It tells you where the middle is. Okay, that's it. That's all the new stuff, I think. Okay, you're confused by the axis of symmetry?
Yeah.
Alright, so if I drew, well, this axis of symmetry would just be the y-axis for this one, because it just goes right down the middle, and it would be called x equals 0. Because all the x values are 0 right here. If I drew one, let's say out here, at -4 to the left, the axis of symmetry would just be x equals -4. That's what this line, that's the equation that represents this line. Alright. And it always, so if this vertex is at -4, 0, the x coordinate of the vertex should match that. Okay, so number 1. You guys ready? You got a lot of blanks to fill in again. Oh, 9 and 10. We might... I forgot about that. I forget about that every year. I think we're going to save 9 and 10 for them. Okay. Yeah. I don't know if it's worth it. Okay, let's just get started. Number 1. What is the vertex on number 1?
The vertex.
Okay, what does that minus 2 do to the graph?
Moves it
Right 2. What does the plus 9 do? Up 9. What point is right 2 and up 9? 2, 9. So on number 1, vertex is at 2, 9. Okay, what's the line of symmetry? Okay, I was wrong. They call this the line of symmetry. Some books call it the axis of symmetry. I didn't remember. The line of symmetry is the line that goes right through the middle of the parabola. It's always going to be x equals basically whatever the x coordinate is of the vertex. X equals 2. You do need to put x equals 2, not just 2. Okay, what is the value of a? You guys remember when we did quadratic formula and we had the a, b, and c value? What was the a value? Yeah, the thing in front of the x squared. So it's basically the value on the front. So on number 1, what value is in front of the x? 1. Because they didn't put a number in front. Okay, that a value tells you if the a value is 2, it's going to go up twice as fast. If the a value is 1/2, it's going to go up half as fast and be broader. If it's negative, it's going to flip upside down. That's what the a value tells us. Which direction is number 1 going to open, up or down?
Up.
Up, because there's no negative in front. What was the last thing? Is it going to be steeper, flatter, or the same as a normal x, y equals x squared? Okay, how do you know it's the same?
It's a 1.
Yeah, if this is a 1 or a negative 1, it's not going to be any steeper than normal. So it's going to be the same. If the number on the front is bigger than 1, it's going to get steep. If the number on the front is less than 1, it's going to be flatter. Okay, number 3. Where is the vertex?
2, negative 4.
Okay, the minus 2 on the in the parentheses moves it right 2.
2, negative 4.
So it's positive 2, negative 4. So it's the opposite of the first one. And the same as the second one. Alright, where is the line of symmetry?
2.
X equals 2. What is the line of symmetry, I should say? X equals 2. Just matches the x coordinate of the vertex. Alright, what is the value of a? What's the front value? 3. Is that going to open up or down?
Up.
Up, because there's no negative in front. Is it going to be steeper, flatter, or the same as normal?
Steeper.
Steeper, because the 3 will make it go up 3 times faster. So it's going to get steeper. Okay, number 5. So what does that plus 1 do to the graph?
Left 1.
Moves it left 1. And if there's no number out to the right of the parentheses, what does that mean?
0.
Means it's not going to move up or down any, 0. So it's negative 1, 0 is where the vertex is going to be. What is the line of symmetry?
Negative 1.
X equals negative 1. Okay, what's the value of A? What's the front value?
Negative
Negative
5.
5. 1/4 is on the previous problem. Okay, is that going to open the graph up or down?
Down.
Down. Negative in front opens the graph down. Is it going to be steeper or flatter than normal?
Same. Oh, wait, I can see.
5.
Flat.
5 in front is going to make it go
Steeper.
5 times faster, so it'll be really steep. Yeah, so normally it would go up 5 times faster, but since 5 is negative, it's actually going to go down 5 times faster. Okay, number 7. Oh, darn. Okay. On number 4, where's the vertex going to be?
Negative 7, 0.
Number 4.
Oh, 4. Negative 60.
Okay, notice on 4, there's no number in the parentheses with the x. There's nothing with the x, it's just x squared. So that means it's not going to move left or right at all, the vertex. So the x coordinate of the vertex on 4 is 0. The -6 on number 4 is not right next to the x, it's after the squared. So that is telling us it's going to go down 6.
Wait, where is the number 4?
Because it's different.
Oh.
So do you guys see the difference between 4 and 5?
Yeah.
On number 4, the -6 is after the x squared, so that's the up or down number. On number 5, the +1 is in parentheses with the x, so that's the left or right number.
So
Okay,
number
so-
4, it would be 0, negative 6.
Yeah, I just put. Okay, number 7. So since we talked about number 4, where is the vertex going to be at for number 7?
7, 0.
No. Okay, there's,
Oh, you just said that. 0 said.
yeah, there's no number right next to the x, so it's not going to move right or left. This is not number 7, that's number 4. Any. It's not going to move right or left any. It's going to stay in the middle, 0. But the +7 is going to do what to the graph? Make it go up 7. So 0, 7 is the vertex. What is the axis? What is the line of symmetry?
X equals 0.
X equals 0. Okay, what's the A value? What's the front value?
0. Oh, negative 7.
-7/4. Is that going to open the graph up or down?
Down.
Down, because it's negative. Is this graph going to be steeper or flatter than normal?
Steeper.
Steeper. 7/4, even though it's a fraction, it is more than 1. It's worth 1 3/4. So it is going to be a little bit steeper than normal. Okay, I tell you what, for 9, it really should be a separate lesson, that's my problem with it. 9 and 10 are the same. But maybe I'll just do 9 with you guys.
Should you do 9 with us, then 10 for bonus?
Well, yeah, but it's got a lot of questions. I don't know if I want to do 10 bonus or not. Yeah, fine. I'm okay with that. We can do 10 for bonus. Okay, number 9. So when it's written in standard form, you guys remember quadratic formula? Just erased it. X is equal to
X is equal to b
negative b
plus or minus square root of b minus 4 squared minus 4.
Getting there, we started to get there. Anyway, like I said, I'm not going to make you memorize it this year, but you will eventually eat it in your brain. So, do you guys remember this thing we called the discriminant? Was that like 2 days ago? Yeah, 2 days ago. Because it tells you what kind of answers you're going to get. It comes out positive, you get 2 real answers or 2 rational answers. It comes out negative, you get not real answers. If it comes out 0, you get 1 rational answer. Anyways, this thing right here kind of gives you the middle of the parabola. In other words, it gives you the x-coordinate of the parabola when the equation's written in standard form, negative b over 2a. So on number 9, what's my A, B, and C?
1, negative 8, 9.
1, negative 8, 9. There is another way to do this, but this is the way I taught, and I think it's definitely the best. The easiest way I could think of. So, negative 8 is 8 over 2a, 2 times 1 is 2. 8 over 2 is 4. That's the x-coordinate of the vertex. Okay, guess how we find the y-coordinate?
You do the other part?
No. Well, f of x is basically like the y about the y, right?
Yeah.
So if I just plug the x in, 4 here and here, and work that out, that gives me the y value that goes with it. So if I plug in 4, I get 16 minus 32 is negative 16 plus 9 is negative 7. And that's the hard part on finding the vertex. So I use negative b over 2a to find the x-coordinate, and then I plug the x in to find the y-coordinate. That's it. Alright, and then what's the rest of it? The line of symmetry is what?
4.
Right there. X equals 4. What's the value of a?
1.
1. The number in front of x squared. Invisible one. Is it going to open up or down? If x squared is positive, if it's a 1 and positive 1 in front, it's going to open up. And is it going to be steeper or flatter than normal?
Same.
Or same. Same. Because we're multiplying by 1 in front. Alright, so I'll make 10 optional for bonus. Oh, they do an example 6. I just looked up at it if you want to see another example. They use the negative b over 2a thing. Alright, number 11, graphing. The part you've all been anticipating, couldn't wait. We're finally here. Oh, by the way, yeah, we got a weird schedule tomorrow.
No class?
So, no, I didn't say that. I think might be like a
Half class.
30-minute, half class, or 25-minute. So, I don't know. If you guys don't get done with this today, I might let you work on it tomorrow. It's kind of a big one with all these
Or we
graphs.
could stop here.
No,
and then, like,
no. We're gonna finish the odds today, but if you guys don't get done, I'll let you work on it tomorrow. 11.
Whoops.
Okay, this is going to be very similar to yesterday's. There is one new trick. I think we've done it before in a different chapter, but. Okay, step number 1. Where is the vertex? For 11. Positive 4. I think they're working in the back.
Weed whacker.
They're putting a new toilet in the guy's bathroom, I think.
Oh,
It's probably like a power tool of some kind.
no bathroom break today.
No, you can go in there. Oh. Might be noisy.
Alright.
Can't wait, can you? 4-2. 4-2 is the vertex, right? And we know it's going to go up from there. So maybe I should have put my x-axis lower. It's too late for you guys. Because I know it's going to go up, right?
Yeah.
Okay, what would be a good x value? So I already know 4 and 2 go together. So if I plug in 4, I should get 2. But what would be another good x value to plug in? Okay, I don't want to plug in like 0 or -1 because I know the graph's going to look something like this. So if I plug in 0, I'm going to get a gigantic number. If I plug in number -1, I'll get an even bigger number. So I want to choose x values that are close to this so that they're not like off my graph. So what x value is close to 4? 3. 3 and 2. Yeah, those would be 2 good ones. So if I plug in 3, x minus 4 is what it goes to.
How many things do you want to say?
Just like yesterday. 5.
5.
If I plug in 3, what do I get? 3 minus 4 is -1 squared,
Is 1.
positive 1 plus 2. So 3, 3. And actually I only need to do one more of these points because I'm going to use symmetry. 3, 3. If I plug in 2, 2 minus 4,
-2.
-2 squared, 4 plus 2, 6. So 2, 6. 2, 3, 4, 5, 6. Okay, now guess what I'm going to do.
Like the thing.
Just use symmetry to draw the right side of the graph. Alright, 13. X minus 1 minus 3. Alright, question 1. Let's do somebody besides now Wonders Andrew. Where is the vertex? I know a lot of you know this. If I can hear you, alright, Cadence, what is it? Right, 1 down 3. Ding, ding, ding. So, or you could say it's -1, -3. What x values would be good to plug in? Just choose something close to this one.
0.
0 and 1. Those will be. You could we could also have done like -2, -3, but negatives are usually a little more tricky for our brains. So if I plug in 0, 0 minus 1, -1 squared,
1,
-3.
-2,
If I plug in 1, 1 minus 1,
0,
squared,
0,
-3.
-3.
Whoops, what did I do?
Opus range.
Oh, sorry. Duh. Okay, guys, I put -1, -3. What should I have put? +1, -3. You gotta call me out on that stuff. Alright, so basically I wrote up here -1, -3 twice, like the vertex, because I put the wrong. Anyways, so 1, -3, that was right. 0, -2. Okay. If I plug in -1, here we go. That's -1 minus 1. -2 squared, -3. That should have been -1, 1. There we go. That makes more sense.
It's stuck in my head now. I need to even get it out. I know exactly what it is now. What do you know that? My personal stress relief. I thought I'd bring out something from my personal collection. Like, okay, that's it's the only one that exists.
15. f of x equals x plus 3 squared. Okay, where is the vertex gonna be? -3, 0. Gonna be going up also, right? What would be another good x value to plug in besides -3?
-2.
-2, -1. Okay, if I plug in -2, what's -2 plus 3
1.
squared?
1.
Okay, if I plug in -1, what's -1 plus 3
2.
squared?
4.
So -2, 1, -1, 4, 1, 2, 3.
Everyone was here. How many people shouldn't have it here? 0.
Oh, God, shut up.
Someone would have told us, no, it's your turn. You never needed nice.
You guys done?
Yes.
Done?
It's a banger tile. I mean, not tile,
What the frick?
What? I mix up tables
17.
and the K.
f of x equals -x plus 4 squared.
I know, but it wasn't cut.
What's different about this graph?
It's gonna go down.
It's gonna go down. So that means we might want to put our y-axis high or x-axis high, since it's gonna go down. All right, Keziah, where's the vertex gonna be?
At -4.
-4 what?
-4, 1.
-4 1. Right. All right. What would be some good x values to plug in? -3, -2. If I plug in -3, do -3 plus 4 1. 1 squared, I'm doing order of operations. 1 squared is 1. Then add the negative, -1. Plus 1. I plug in -2. Plus 4 is 2 squared. -4 plus 1
is 3.
-3. -4, 1, -3, 0, -2, -3.
Literally so much. It's not even funny. Literally kidding. I'm literally punch you in the face. You think I'm kidding? No, I'm not kidding. Starts cracking his knuckles. Think I'm kidding? He's establishing I'm not kidding. What is happening? We're mocking Sebastian.
Oh.
Okay.
Oh, boy.
Sometimes you wanted to punch Isaac in the face.
Oh, that was
wasn't
really
even
funny.
doing anything that day. It was more standard.
It was funny.
You
Oh,
laughing.
punch him in the face.
Alright,
Oh, me.
we might be in big trouble on this one.
Big trouble.
Biggie, wiggy, trouble, wiggy.
Okay, what's, on 19, what's that 3 in front gonna do to the graph?
Make it narrow.
Yeah, it's gonna go up really fast, make it narrower. So that means the graph's gonna get really big really quickly. So I think what I'm gonna do is count by, I don't know. I think if I put the x-axis at the bottom and count by 2s, we should be okay. So I'm gonna do that. But where is the vertex gonna be at for this one?
Oh. Yeah.
Okay, I know it's going up because that's positive, so I put the x-axis down low. So the vertex is at -1, 4. Now here's the problem. If you're counting by 2s, you need to label your graph first of all. Just put a couple 2s out there. But when you go to graph -1, 4, you have to remember that you're counting by 2s. So where would -1, 4 be? Middle, and then up. Yeah. If you want to count by 1s, you can, but it's going to be really tall, is the problem. -1, 4 is the vertex, but since we're counting by 2s, you kind of only go half as far as you normally would. Okay, what would be another good x value to plug in?
0 and 1.
Yeah, let's put -2 right there. 0 and 1. If I plug in 0, 0 plus 1 is 1, squared is 1, times 3 is 3, plus 4. A lot of work on that one. Plug in 1. 1 plus 1 is 2, 2 squared, 4 times 3, 12 plus 4, 16. So that's why we need to make our graph really tall, 16. So 0, 7, maybe just so we don't get confused, maybe I'll count all the way up here. Where is 0, 7?
Like half.
Right between 6 and 8. All right, and then where is 1, 16? So 1 is right there.
Up 8.
16's in the way. Oh no. There. Okay, make the twin. So this is the middle right here, so this would be like the reflected image. So it's really skinny.